Problem 7.21. So to consider we have a uniform random variable x. It's uniform between 0 and 1. Sorry, 1 and 3. So the probability density function should be 2, right? Because should be 1/2 because the interval has a length of 2. And now the first question is to find the PDF of y, that's the absolute value of x. The second question is to find the PDF of z, which is the fourth power of x. Okay, so let's first look at the first question. The x is uniform 1, 3, so we know that x can only take a value between 1 and 3. So that's 1, 2, 3, 0, and this is the 1/2. So you take a value, positive value, constant value there, and 0 outside. So that is this guy here is the probability density function of x. So x is between 0 and 1, and absolute value of x is still between 1 and 3. Sorry. So the absolute value of x is still between 1 and 3. That means the absolute value of x is just x itself. Okay, y equals to absolute value of x, and then the y can only take a value can only have a positive probability between 1 and 3 as well. Actually, you can see that y is essentially just x itself. But in this case, if you try to use the method we learned in class, then we can define this function ux just equals x itself. So the inverse will be just the identity as well. And the PDF of y, according to the formula we had, the PDF of y will be equal to the PDF of x evaluated at the w of y times the absolute value of the w prime at y. So this guy here is just constant, right? Because it's just constant 1/2. Here, this guy here, because it's an identity map, so the derivative is just equal to 1. So the absolute value of y is still 1. So essentially, you just have f of y, and then it's just 1/2. It's the same as the PDF of x. So in summary, the y just has the same distribution or PDF as x. So now the second question. Now the z equals to x to the fourth, to the fourth. So we can define this function u, that is x to the fourth. Then we know that this u is also strictly increasing over the positive real numbers. And that's why it must be strictly increasing over the interval 1, 3, which is the support of the PDF of x. The inverse of the u will be the fourth root, right, of its argument. So now you know that since z equals to x to the fourth, so when x is between 1 and 3, the z must be between 1 to the 4 and 3 to the 4. So that's actually 1 to 81. So z can take any value between 1 and 81, and the probability density there, the probability density over there is this, which is the density function evaluated at w of z times the absolute value of the w prime at z. So remember that wz is this guy. So the f is still constant, right? Evaluated at anywhere, and this is just 1/2. And the derivative of this guy, which is the derivative of this, is 1/4 times z to the power negative 1 over 4. So that's this guy here. All right, so combining them together, we get this. So when z is between 1 and 81, we know that the density function is this value. Otherwise, it will be 0.